All right, so before I start this question, I do want to just preface this with I had a really hard time finding a previously given BC free response question that was limited to the topics that they are doing with regard to sequences and series this year. Generally, most of these free response questions involve Taylor series or Maclaurin series or power series with intervals of convergence and stuff like that, but they cut all of that out because of everything that's going on this year. So this question that I found is all about Taylor polynomials, which I think is a great one to go over, especially considering that our tangent line is basically a Taylor polynomial, and then we build upon that. And then the quiz itself that I'm giving you today goes back over geometric series test, p-series test, alternating series test, and ratio tests, which are the additional things that you need to make sure that you're familiar with. They just don't have any of those in a previously given free response. Okay. So it says a function f has derivatives of all orders at x equals 0. Let p sub n of x denote the nth degree Taylor polynomial for f about x equals 0. So just to remind you of when you're creating your Taylor polynomials, and what maybe I'll do is I'll move this down so that we have a little bit more space. Okay, oh great. Of course. Copy, delete, there we go. All right, so when it comes to creating a Taylor polynomial, so your Taylor polynomial, which we'll call t sub n of x, okay, remember it begins as a tangent line. So it would be f of a plus f prime of a times x minus a, okay? Technically, even though you don't see it, this is raised to the first power, and this is over 1 factorial. So therefore, when you start getting into the next part of this, hopefully you remember some of the other components. So then this would be, next one would be f double prime of a. It would be times x minus a squared, and that would be all over 2 factorial. And then I'll do the next one, f triple prime of a, all over 3 factorial times x minus a cubed, and so on and so forth until you get to whatever degree polynomial you're creating. If it's a third degree polynomial, you stop when you get to n equals 3, so raised to the third power, third derivative, 3 factorial, not the third term, but actually where n equals 3. If it is a Maclaurin polynomial, a itself is actually 0, and that's actually a majority of what we're working with in this question. So it says for the first one, it is known that f of 0 equals -4, like p sub 1 of 1/2 equals -3. So this is a little different than some of the ways we've done stuff before. It says show that f prime of 0 is equal to 2. Okay, so let's start with the fact that you're doing a Taylor polynomial, or really Maclaurin polynomial in this question, right? So t, in this case, we're working with t sub 1 of x, which means you're basically just doing a regular tangent line right now. Maybe I'll even call it p sub 1 of x, okay, is going to come from f of 0 plus f prime of 0 times x minus 0. Okay, that's in this particular case because, again, you're centered at 0 and you're working with p sub 1. Okay, so if I take the information that's provided and I plug in, we know that p sub 1 of 1/2, so p sub 1 of 1/2 actually has a value of -3. So I can make my left side -3. F of 0 is equal to -4, so I'll bring that down. F prime of 0 is what we're actually looking to calculate, so I'm going to leave that as f prime of 0. And then x minus 0, the x that you're plugging in was 1/2. So obviously 1/2 minus 0 is just 1/2, and you can now use that to solve for f prime of 0. So I would add 4 to both sides. So you would see that comes out equal to 1, f prime of 0 multiplied by 1/2. If you multiply both sides by 2, you end up getting 2 equals f prime of 0. Okay, so that's all you need to do for that first part. For the second one, it says it is known that f double prime is equal to -2/3, f triple prime is equal to 1/3, and it's asking you to find p sub the third degree Taylor polynomial. Okay, so again, remember you're centering it around 0, so I'm going to write the general setup first. P sub 3 of x, or t sub 3 of x. Remember, it begins as the tangent line. F of 0 plus f prime of 0 multiplied by x minus 0, plus f double prime of 0 all over 2 factorial times x minus 0 squared, and then finally f triple prime of 0 times x minus 0 cubed all over, all over 3 factorial. Okay, so if you notice, you're reusing your values from the previous problem, because again, you're still making the same polynomial centered at the same point. You're just now extending the terms, which remember gives you a better approximation for what's happening. So p sub 3 of x, okay, so again, using the previous parts of the problem, f of 0 was equal to negative 4, f prime of 0 was equal to 2. Obviously, x minus 0 is just x, so I'm going to leave that as is. Plus, and remember, you don't need to simplify, f double prime of 0 is negative 2/3 all over 2 factorial times x squared. And then f triple prime of 0 is 1/3 over 3 factorial times x cubed. And as I mentioned before, don't bother simplifying. Why risk making any mistakes? Just box that off. That's all you need to put for that answer. I will say that you can't leave it as f of 0. You have to actually put in the negative 4. But beyond that, you don't need to simplify anything. Okay, so then the last question, it says the function h has the first derivative given by h prime of x equals the f of 2x. It is known that h of 0 equals 7. Find the third degree Taylor polynomial for h about x equals 0. So once again, you're making a Maclaurin polynomial, but this time it's for h. It's not for the previous function we were just working with, although we're going to have to use those values to be able to get the values we need. So let's write the general one first. So I'm going to call this t sub 3 of x. Okay, we're centering around h, where you're plugging in 0. So begin with the tangent line. H of 0 plus h prime of 0 times x minus 0 plus h double prime of 0 divided by 2 factorial, not h, okay, times x minus 0 squared, and then h triple prime of 0 all over 3 factorial times x minus 0 cubed. Okay, so now let's start plugging in some of the values, and actually maybe I should do a little bit of derivative stuff first. So we have h of 0, okay? We know h of 0 is equal to 7, so let me write that down. We know h of 0 equals 7. H prime of 0. H prime of 0 will be equal to the f of 2 times 0, which is the f of 0, which they gave us in the original problem is negative 4. Okay, h double prime of x. Let me start with it in general. You have to use the chain rule. Derivative of the outside would make this f prime, keep the inside the same, which would be 2x, but then you multiply that by 2. So specifically, h double prime of 0 would be f prime of 2 times 0, which is still 0, but you now have to multiply that by 2. So now again, when you go back to your previous problems, f prime of 0 had been actually 2 itself. So this comes out to be 2 times 2, which equals 4. And then last but not least, and I'm sorry I'm doing this all over the place, h triple prime of x is once again going to be using the chain rule. Okay, so that 2 is a constant, will stay out front. Derivative of the outside becomes f double prime. Inside stays the same, multiplied by the derivative of the inside. Okay, so h triple prime of 0, I'm going to put those 2's together to make it 4 times f double prime of 2 times 0, which is really just 0. Okay, so 4 f double prime of 0, they gave us in the previous problem, is negative 2/3. Again, why bother simplifying? Okay, honestly, you could have even have left that as 2 times negative 2/3. Leave an unsimplified answer so you don't risk making any mistakes. So now when I go to this and I go to fill in, h of 0 was given to us that it's 7, okay? H prime of 0, we'd figure out was negative 4, and again, x minus 0 you could just leave as x. H double prime came out to be 4, so 4 over 2 factorial times x squared, and then finally, last but not least, again, I would just leave it 4 times negative 2/3 over 3 factorial times x cubed. I mean, again, if you want to simplify, fine, but if they're going to accept unsimplified answers and you don't want to risk making any mistakes, I really feel like you should probably try not to risk making any mistakes, okay? So again, this covers all of Taylor polynomial stuff, or really actually this one is Maclaurin, but even still, it's the same idea. And then like I said, the quiz itself will go back over the different series tests that you need to be aware of. Again, there are a bunch of series tests that are eliminated. So like for example, you don't have to worry about integral tests, you don't have to worry about any of the comparison tests, you don't have to worry about absolute versus conditional convergence, or the alternating series error bound, or the Lagrange error bound, or radius of convergence, or power series stuff, or Taylor-Maclaurin series stuff. All of that was cut out. You just have to worry about convergence tests as in geometric, p-series, alternating series, and ratio test. And then you also have to make sure that you're familiar with Taylor and Maclaurin polynomials, okay? Like approximations and things like that. Okay, thanks so much, guys. Good luck.